So here's a couple to try. Why don't you see if we can figure out how these would be set up? Take a pause, take a stab at them. Okay, assuming you have now done that. So this one, you have to think about, what's going on in the integral. I have 1 over cube root x, so, it's a pretty good guess that that has a vertical asymptote at 0, and, any look at the graph will bear that out. All you'd have to do is take this graph that we already had, change the 1/2 to a 1/3, dink, dink, and, the same picture. How about that? The difference is it's because it's an odd exponent, it actually has 2 sides to it. Yeah. All right. So we do the integral by doing that. What this is going to equal is the, so you have to think, where is the undefined limit? It's this one up here. So we have to do the limit as, and I guess we're doing the negative side right here, right? So we're going from -8, from x equals -8. So what it changes is, excuse me, I'm trying to get my iPad to become vertical and it won't do it. All right. Our integral now is from -8 to 0. So that means as we do the integration, we're not approaching 0 from the right this time, we're approaching 0 from the left. Right? And the 0 that is problematic is our upper limit. So what this equals is the limit as b approaches 0 from the left of the integral from -8 to b of, and let's go ahead and write that as x to the -1/3 dx. All right, but this is the crucial step, is to rewrite that integral as a limit. And then from there, we just do anti-differentiate and all those things. So this is limit as b approaches 0 from the left. So the antiderivative of this is 3/2 x to the 2/3, right? Yeah, 1 more than -1/3 is 2/3. Flip it over and multiply. That's the same as dividing. And we're going from -8 to b. So this equals the limit as b approaches 0 from the left of, so we're going to put in the upper limit first. So 3/2 times b to the 2/3 power minus 3/2 times -8 to the 2/3 power. All right. And then so this equals the limit as b approaches 0 from the left. I kind of gorfed that a little bit. So we're doing the limit of this bit, which is 3/2 b to the 2/3 power. And then this part, so we can just evaluate because it's not part of the limit. So we just have to watch the sign. So a tricky thing about this fractional exponent is the numerator is a power. That means I'm going to take 8 and square it and then take the cube root. It's going to be cube root of 64. It's going to be +4. Or alternatively, I could take the square root of, the cube root of -8 is -2, and then square it, I get +4. So this -8 to the 2/3, because the numerator is even, becomes positive. All right, +4 times -3/2 is -6. So -6. This limit, so if you look at just b to the 2/3 power, that is a function that is decreasing as, well, I mean, really, it's an increasing function, but as b approaches 0 from the left, means we're going like this. That graph probably looks like this as we're approaching 0. Anyway, we can evaluate the limit by substitution here. This is not undefined. So this equals 0 minus 6. That one is -6. All right, how about this one? So this time, yeah, again, it's the upper limit that's undefined, right? So, I guess I wanted to talk about the fact that this area is -6, right? So why is that area negative? Because we're looking at the area from -8 to 0. It's all below the x-axis. The function is below the x-axis. So that stuff is all negative. That area is all going to be negative. Okay, this one, so we're going to say this is the limit as b approaches 0 from the left, and this is all the key, is just writing this as a limit of the integral from -2 to b of, and we'll write this as x to the -3rd so that we can integrate it, and that is equal to the limit as b approaches 0 from the left of, let's see, so this is going to be negative x to, it's going to be x to the negative 2 divided by negative 2. So that's going to be negative 1 over 2x squared, right, from negative 2 to b. Okay, so then that equals limit as b approaches 0 from the left of, so we're going to put in the b first, so we have negative 1 over 2b squared. And then when I put in the negative 2, we can think about the sign ahead of time. So I put in the negative 2, I'm going to get positive 4, positive 8, negative 1/8, minus for the fundamental theorem, so I get plus 1/8. All right, does that sound right? Yeah, okay, it does sound right. Okay, now, then I'm going to get limit as b approaches 0 from the left of negative 1 over 2b squared plus 1/8, right? This limit only applies to this now. And now my denominator is approaching 0 while my numerator is bounded. So this limit is approaching infinity, which is kind of interesting to think of this, in terms of a graph. Negative 1 over 2b squared is going to look like this. So that's it's an even asymptote. So as b approaches 0 from the left, negative 1 over 2b is going to be approaching negative infinity. So this is negative infinity plus 1/8. In the same way that infinity minus 1 is equal to 0, negative infinity plus 1/8 is still going to be negative infinity. But essentially, I'm taking infinitely many negatives and adding a finite positive to it. The result is still going to be negative infinity. And then that also makes sense in terms of the graph. So if I look at this graph and I want x to the negative third this time instead of x to the negative 1/3. So let's see if we can get up there. X to the negative third, right? So understandably, looks like that. So we're doing the integral from negative 2 to 0. Oh, you're going to flip over on me. We're going to do the integral from negative 2 to 0. Here's negative 2 right here to 0. So doesn't it make sense that this area this time is going to be negative infinity? Because it's all below the x-axis here. But it turns out that this particular integral is infinite. Yeah, I wonder if there's some way you could predict ahead of time which ones are going to be infinite and which ones are going to have finite values. And we're just doing these integrals of 1 and an exponent. Which ones are going to be infinite, which ones are going to have finite values. That would be worth thinking about. Like 1 over x squared. I wonder if there's a way you could predict that ahead of time. Spoiler alert, there is. All right, now the next thing we're going to do is this one, and this one's got another trick to it. We have to break up the integral. I suppose I'll get this one started and then see if we can finish it for the next video. So the idea here is I have a vertical asymptote at x equals 1. Right, so if I try to graph that, it's dx over x minus 1 to the 3/2 power. I guess I'll save it to the next video because time. All right.